Okay everyone, so here's my follow-up review as promised on the Prusa i3X, and this time it's running with all the mods and upgrades that I put on it. So we kind of get to see the differences. Even though I know I didn't show it printing last time, you'll get to see the differences in the overall layout, and I kind of explain what everything does. So I don't have the original Carriage, this original XE Carriage to show you, but you can look at it in the other video. You can tell these are the new ones I printed. They're much cleaner, they're lighter weight, and honestly the other Carriages were fine. I would have left them on the unit, except that down here, I don't know if you can see here in the video, but over here, this little Z-rod nut, yeah, you can see this. So this Z coupler nut here, on the original unit, the threaded mount point for this Carriage is on the bottom down here, not on the top. And the reason I decided to go ahead and print these plastic Carriages is because the closer that threaded nut is to the coupler down here, the more misalignment problems get transferred into your whole assembly up here, and that causes waves or lines in your print. So basically I've been trying to chase the perfect print that comes out with no lines or waves in it. I want a perfectly clean model where there's no irregularities in the surface. This shouldn't actually be there. I have a demo here, I'll show you in a second. Show you what a big difference this makes. But first I'm going to adjust the focus here so we can see something better. Okay, right here. Okay, so I'm going to get the flashlight. So see right here on this vertical assembly, I don't know how well this is going to show up, but up here near the top, you can see the lines. You can see the waves that are sticking out, caused by misalignment on the different layers. And that's caused by this whole Carriage assembly wobbling around and moving during your print. And I don't know if you could tell, but down here near the middle, there's almost no waves. It's pretty much smooth. You can see there's no ripples, you can feel it, and it's smooth. That's what I wanted, or that's what I wanted from a printer to be repeatable, is nice smooth surfaces, because when you go to print something that has internal holes or internal parts or slots for nuts to go in, those waves end up making the diameters of your parts wrong, because they essentially make the internal recesses and stuff smaller. So diameters and holes drop, like for instance the diameter right here in this threaded house, this little housing here for the bearings to go in. Those bearings are actually tighter than they should be. If it printed out smooth, they would actually fit in there better. So anyway, that's what it looked like before. And that was even with this new X Carriage. This is the new X Carriage I told you I was going to print. Much lighter. You can see how much smaller it is. And it's way closer to the rods. You can tell it's only about 1/4 of an inch from the rods. And if you watch the nozzle here as it's printing, you can tell there's no wobbling or jiggling down there on the hot end. It's very stable and connected to the body up here. There's no shake or play. But even with that, I was still getting waves in the prints. So that's when I decided to go ahead and print these new plastic X-axis or XZ-axis parts. And in doing so, that would place this threaded nut further away from the coupler and thereby reduce my waves, which I could tell were there because the top of my prints, such as this, which I don't know if you could tell, but the top of the prints like that came out perfectly smooth, but down here where it started, there was waves everywhere. So I knew that my wobble was being caused by play in this motor and this shaft not being straight. So anyway, here's a new sample of the way it's printing currently right now with all the mods. I'm going to try and get this focused right here. I'm just going to focus on this really quick so we can get the correct focus. Okay, so right here, this is just a standard cube I printed with a perimeter of 2 and a wall thickness of 1 millimeter. So basically 2 perimeters at 1/2 millimeter. And I don't know if you can tell in the video, but when you're looking past the edge of it, right there, there's no lines or waves. And if I move this out here and shine the light across it like this, there's no irregularities on the surface. All you can see is the actual print lines from the printer. Everything else is perfectly smooth. That's what I was trying to get from prints. That's the way the printer should print out of the box. But of course, you never get quality parts, so there you have it. A cube that's perfectly smooth, perfectly flat. This was printed at 2x scale, so it's 2 centimeters square, just to make the flaws more obvious, if there were any. And then, just to see what would happen, I also printed it at double that speed, which was around 30 millimeters a second. So I printed this at almost 60, 50 or 60. And there's only one spot in there where you can see a line, and that's because I kept changing the speed. So where you see that line there, kind of in the middle, that was me just speeding the machine up because it wasn't printing fast enough for me. And either I bumped something the wrong way or I just didn't do it smoothly. So other than that, you can see there's really no ripples or waves. So yeah, great prints, great print quality. But overall, everything I changed was the new carriage here, which you can find on my Thingiverse page. I'm placing all the links for all of these models and parts on Thingiverse. So just look in the description of the video and everything will be in there for these pieces. Gotta fix the filament here, it's decided to fall again. It's just a test sample, so it's not actually on a spool. So basically, yeah, I printed the new carriage. This is the new blower nozzle here. I don't know, this flashlight may be throwing off the camera, but let me readjust the focus here. Right there. Okay, so this is the new blower assembly here that I designed. This design was by someone else, but the blower nozzle I changed. I love the fact that it blows right on the actual printed area of the part, because it keeps it from overheating small parts, especially toys and stuff. When you're printing, you have arms and legs on little characters and they start melting from the heat of the tip. Well, with this new blower nozzle, it cools it and keeps it from melting on you. And I also added on my own little nozzle coming off the side here, and the reason I did that was because when you're printing something like this, at the moment I'm printing at 260 degrees Celsius with a cold bed, but that 260 degrees travels up the stem there in the extruder up into this aluminum body, and that can cause these parts up here to get really hot. You don't want to get the motor hot, the extruder motor, and you certainly don't want to get this aluminum body too hot because you're going to start melting the plastic housing it's hooked to. So this blower nozzle basically cools that area of the stem above the heating block and keeps that heat from going upward, which is also a good thing because inside there's a little Teflon tube, and that Teflon tube, you don't want it to melt the filament before it gets down to the heated tip and cause it to jam. So that prevents jams from happening as well. So that works awesome. And then as I said earlier, I printed these new brackets. These brackets had to be a little bit modified. These are the i3 Wework Brackets. But I had to modify the spacing because the threaded rod on most Prusas is much closer to the smooth rod, and on the X model for some reason they space them further apart. So I had to move the nut further out, and also the standard is a 5mm threaded rod and these are 8mm, so I had to adjust that a little bit. I did get a little bit of warpage here. I don't know if you could tell that this corner up here is a little bit lower than the middle here, and the same on the other side. They started coming loose from the printed bed. I printed them cold on blue tape. This one was the worst. This one's actually curved quite a bit, but it still lines up barely. This one didn't do it as bad. I would say when you go to print these parts, print them with a brim or a skirt they call it of at least 4 or 5mm, and that's just a layer of plastic that extends out here from the base when it's printing, and it helps the part not come loose from the print bed when it's trying to dry and shrink. And those are PLA, so even with PLA I had problems with shrinkage and coming loose from the bed. If you printed in ABS, it'd probably be a nightmare. So do them in PLA with a heated bed, or with a brim of at least 4 to 5mm. This is yellow here because I had to redesign. Turn the flashlight off. This little part here is yellow. I had to reprint it after I printed everything in black because my measurements were a teensy bit off, and this little screw just goes down and hits the end stop switch. And that of course gives you an adjustment to adjust your zero position. Pretty much everything else worked really good. I did have to take a 5/16 drill bit and remount these recesses for the 8mm rods, but all it took was a little bit of smoothing to get the rods to go in, and they're very snug, which is great because you know there's going to be no wobble or movement on that mechanism. In fact, this whole mechanism is so tight you can hold one end and the other end doesn't even move. So even if it's suspended in midair. So there you go. That's all the upgrades. Oh, forgot the last one. To get my perfectly smooth prints with no Z-wobble, to eliminate it 100%, I would say they were almost perfect before I put this part on here, which I'm going to change the focus again here. Right here. What these are right here, I don't know if you can see them, but they're kind of clear whitish, and then there's one right here between the motor and the housing. These are printed in a flexible TPE. The shore hardness was 80, so it's actually softer than NinjaFlex. And I purchased that filament from filament.ca, which is a Canadian filament supplier. And that was the softest stuff I could find around. I couldn't find anybody who made anything softer than NinjaFlex. I didn't know exactly what I wanted, but I knew I wanted something really, really soft and flexible. And it turned out to be a tad too stiff, but oh well, I couldn't find anything softer. But what these are is basically isolators for vibration, and at the same time, their main function is to allow you to adjust the direction that this motor is aiming. Because by default, this mount is not perfectly straight. So when you go to drop this threaded rod down into the coupler, I would say probably 90% of the time it's not going to be lined up. You're going to notice that this threaded rod does not drop into the coupler straight like it should. It's going to hit one edge and it's going to be off center, and that means that this coupler is already twisted when you attach it, which is going to make a lot more play and wobble, which will cause waves in your prints ultimately. So ultimately you want this rod to be as straight as possible. You want the mount point to be as high as possible on the carriage, and also of course that makes it further away from the coupler. And last but not least, you want the coupler and the motor to be pointed straight at the rod. So make sure your rod is centered in the top here. Some people drill these out at the top so that they can wobble around. But make sure when you're checking it that the top is held perfectly centered. And then if you print these are on Thingiverse, if you print them in NinjaFlex or something similar, really, really soft, you put one above the motor and one between the motor and the frame. All you have to do is make these screws touch, and then go back and undo this rod here and pop it out. And you can sit there and adjust these screws, and if, let's say it's pointing off to the left here, all you have to do is tighten up the screws on the left side, which will compress these gaskets and aim the motor back towards the right, so you can adjust it and make sure it's aiming straight at the rod. So that's what I finally had to do to make sure that the motors were pointed straight up along this entire rod and the axis, and then I finally got the perfect prints. So there you have it. The only thing I forgot to say in the last video was on the extruder here. Adjust the focus again. I'm going to pause. Okay, so on the extruder housing here, you can see it in the video. On the extruder motor is not the default gear. The default gear is just a 30 or 40 tooth, I don't remember how many, just like a brass gear that drives the filament. The only thing I didn't like about that gear was sometimes if you were having problems with the filament, whether your hot end was too cold or it was too close to the bed, or something that would cause it to either jam or cause the stepper motor to jam and sit there and pop, is your filament sometimes would walk off center and get jammed on the little extruder tube right there, that little extruder tube that the filament goes into. If the filament doesn't go exactly straight into there, there's a sharp edge down inside where the diameter changes that it can catch on. And sometimes that would cause me jams, because if I was doing a print with a lot of retractions, at some point the filament would walk itself off center. And even though there's an actual idler bearing back there with a centering mechanism on it to keep the filament straight, that bearing is just not tight enough. No matter how you adjust it, it allows the filament to walk back and forth, and that it was probably a good millimeter to 1.5 millimeters is enough to make it jam. So I bought a Mark 7, I believe. I'll have to correct it later if I was wrong, but I believe it's a Mark 7 drive gear. It's an extruder gear, and it has, you can see it in the video there, it has, let me adjust the focus here, it has a concave groove in it where the filament goes through with teeth on it. And that also prevents the filament from ever going off center. So all you do is look from the top here down through the extruder housing as you're working on it, and you make sure and clamp it right in line with the tube at the bottom. And the combination of the two prevents the filament from ever going off center. So that was one thing I had to do to prevent jams from happening. I never have jams anymore because of misalignment of the filament or something like that. So make sure and get yourself one of those and pop it on there. It only costs like $5. And just toss the other gear back in the box. The only thing I had to buy that was non-standard and I had issues was when you go to mount this aluminum Mark 8 plate here back onto the motor. The distance is a little bit off, or a little bit, how should I put this, not common, because you have 3 millimeters of plastic between the motor and the housing. So you can see I have a bunch of washers under these bolts here at the bottom because they're actually too long. And then this one screw right here in the corner that holds the adjustable release lever, that was the hardest one to find. If I remember right, it is a 30 millimeter Phillips drive M3, and they do not make the right length in an Allen head at most hardware stores. So you would either have to order it online, or you would have to get, like I did, a 30 millimeter Phillips, and it barely goes into the motor 2 threads, but in combination with the other screws and everything, it seems to work. So I haven't had it try and come loose yet. So that was the only thing. And I also had to print my own, this little yellow thing on top here. Let me back this up. I had to print my own end stop holder. This little yellow part you see right here is the part that comes over and hits the end stop switch. This was not originally with this Carriage set. I don't know why the guy forgot to put something in there, but as soon as I put it on the printer, started printing, or tried to go print, I realized that there was nothing to hit the switch. So I just manually hit the switch to zero it out over here somewhere, and then printed myself right then something to clip on and give me a way to come over and hit the switch. So anyway, there you have it with all the upgrades, printing perfectly. I'm going to adjust the focus here so you can watch it print. Okay, so as I was saying, this print right now, make sure the focus is right here. This print is the crescent wrench, or wrench as they call it, printable wrench, and I scaled it down to 0.6 because I didn't want to print a big huge wrench. And I also, this is sample carbon fiber strengthened or reinforced filament, and I don't have a lot of it. I only have like 5 or 6 meters left. So I wanted to print a wrench in this stuff and see how strong it was. So I'm printing a 0.6 scaled up version of the crescent wrench. I'm going to see if it's actually functional, usable, and if it is, if I can actually crack the parts, the moving parts apart and get them to work, it should be very strong because this filament has a lot of carbon fiber in it that strengthens it. And I did test, I test printed a fan blade already. This is the fan blade here. I didn't clean it up yet, so this is just some stringing from the blades, but this is printed in the carbon fiber filament, and I'll do a review on it later. But anyway, pretty strong stuff, very, very lightweight, and very hard to actually snap. When you try and snap it off, it doesn't really want to break like normal plastic, so I'll do a review on it later, but I'm just going to let it run a little bit here so you can watch it print this wrench. Just kind of pay attention to the nozzle there, especially how it's moving. Notice the lack of any play or slop. And the one last thing I did forget to mention again was the extruder nozzle down there, or the tip. That is a special extruder tip. made by Micro Swiss. You can order them either from Micro Swiss themselves or you can find them on eBay. They are coated with some kind of special nickel compound. So they're brass nozzle, but they're coated in a special nickel compound with other metals, and it makes them a lot lower friction, and it also makes them highly wear resistant. And when you're printing a filament like this with a carbon fiber infill in the plastic, the carbon fibers are extremely hard and they wear out your brass nozzles and ruin them. So you have to have a special nozzle to print with so you don't wear out your regular brass nozzles. And so far I left the nozzle on there because the default stock one that comes with the printer is a 0.3mm, and I kept having jams no matter how clean I kept the environment, how clean the filament was. It was actually good filament too, or pretty good filament. I kept having jams. So I ended up just leaving this nozzle on here because it's a 0.4mm, and I love it. Everything I've been printing prints amazing from it, and I have not had to remove it yet to unjam it, and I've been printing for weeks. So gotta say, if you want to get yourself a Micro Swiss nozzle for printing carbon fiber or just regular filament, they're amazing. They don't jam. You can force the filament through them a lot faster during a print and not have to worry about the friction of it slowing down and causing the extruder motor to bounce. And yeah, great stuff. I really love that nozzle, so I might go ahead and take a look at that. I'll put that in the video as well. The only one other thing I still need to mention is I found out the other day when I was going to print carbon fiber such as this, and I had it on a heated bed, I discovered that the power supply they gave me with the unit was not the correct one. It was underpowered. And that's also why I mentioned in my last video the wiring diagram for the hookup to the power supply didn't match, because the power supply they sent me was a 15 amp 12 volt output on a single rail, which is common for these. And it has a little sticker right on the side of the power supply that says it, but I never checked it. And sure enough, when I went back and looked at the packing slip, it shows what they actually included in the kit. It says that they included a 20 amp 12 volt output power supply. And I did a little quick search online, and sure enough, everyone said minimum for this style i3 printer is a 20 to 30 amp, no less than 20 amps. So it was running on a 15 amp power supply. Wouldn't really call it running. It does print PLA, but I wondered why the fans would change speed when it would go to print. And in this particular case, I was trying to print some carbon fiber or some TPE, which is flexible filament, and they require a higher temperature to print and a heated bed. And the combination of the two heated at once to really high temperatures meant that it needed a lot of power. And as soon as I would get my temps up to temp, and it started printing, as soon as it moved out here and started moving around, I would look up at the monitor and my temps would be dropping degree by degree, and they would eventually settle probably 10 degrees Celsius below what they were targeted at, and they wouldn't go back up, which told me that there wasn't enough power, because when all the stepper motors started to run, they couldn't maintain that temperature or heat anymore. So that's what clued me in to look at the actual sticker on the power supply, and that's when I found out that it was underpowered. So it only cost me, I think, $30 to buy the correct one. I'll put the link for that as well. And make sure and look for that exact one as long as the link is working, because the one that they show in the instruction video being placed on the printer is the one that I had to order that's a 30 amp. And the reason I'm saying to get that exact one is the hole pattern for it is already in the frame. They have two hole patterns already laser cut in this acrylic frame. If you buy that model, you could take it out of the box and bolt it right under the frame and not even touch anything. They already have all the mount holes for that exact one placed on the frame. And oddly enough, they're so cheap they don't even send you the right power supply with the unit, which is hilarious. So, yep. With the new power supply, the bed used to take probably 15 minutes to go from 30 Celsius for just room temperature up to 70 or 80 Celsius. We're talking straight 15 minutes to get there. Now it takes less than 5 minutes to get all the way up to 80 Celsius, 90 Celsius. And the extruder tip heats faster as well. And of course, when everything starts printing, my temperatures stay stable, nothing drops. So get yourself the right power supply. Who knows what they're going to throw in your box. Check it. If it's 20 amp, it might be okay. If not, just go ahead and buy a 30 amp. The 30 amp works awesome. One thing I also need to mention is that the rods here on the x-axis, as well as the z-axis rods, are now replaced by what people call cheap chromed rods, but they're actually, from looking at these ones, pretty damn nice. They make the stainless steel ones that come with these kits look like trash. The surface of them is way smoother. You can't even see any visible marks or lines in them. They're just phenomenally smooth. I bought these in 3-foot lengths and cut them myself. And the other thing is they are much stiffer, so you have less bounce or movement from the rods themselves, which right here on the y-axis, if you push down on this build plate, you can actually see the entire plate bounce up and down from the rods flexing. The new rods are much stiffer. I have not replaced the Y rods yet. I'm going to. But the X and Z are the new chromed rods. I'm going to put the link for these as well. I bought them on eBay from Geeetech, I believe, which is the company here in the US that supplies printer parts. And I bought them in just 3-foot lengths, and like I mentioned before, cut them myself. So really straight rods. They are not perfectly straight, but for a 3-foot rod, they're the straightest you're ever going to see. I didn't bother straightening them because by the time you cut them down to 300 or 400 millimeters long, the amount that they're off is so slight that it actually is pointless to try and get them any straighter, so I just left them that way and put them on the machine and have not had any issues with them at all. And of course the new bearings I mentioned in the other video, the new linear bearings, put those in these new housings. No binding problems, no noise problems. I'm still running bushings here on the x-axis. You can find them on Thingiverse. They're plastic bushings. Those seem to work the best here. No slop, no play, no noise. And the one other thing was, I mentioned in the other video that the new bearings that I purchased had a little bit of play on them. That actually was not correct. The old rods were not the perfect diameter. They were not exactly 8.00 millimeters. If you put a micrometer on them, they would read out 7.98, especially here in the center, or in the middle where the most wear was. They would read 7.98 millimeters, and I thought 0.02 of a millimeter was not enough to make a bearing difference, but apparently it was. 2/200ths of a millimeter is enough to make a bearing sloppy, and we're talking visible play. So when you buy these chromed rods, they are a really exact diameter. If you measure one end of the 3-foot rod and measure the other end and everywhere in between, all you're going to get is 8.0, 8.0, 8.001, 8.0. So they're extremely accurate. The old rods were not. They were 7.97 or 8 in the middle, and in near the ends they would be like 8 or 8.01. So that's one reason I changed the Z rods out, was because these bearings would kind of bind up down here when you started printing, and up here in the middle they'd get loose. So that caused problems, of course, with the Carriage, because the Carriage didn't want to move up smoothly. So yeah, grab yourself a set of chrome rods. They'll make a huge difference in the way it prints.